Hey students, this is Dr. Ong, and I'm making this video to help you review how plasma proteins affect blood pressure. So let's review the situation that we've got here. We have a capillary, and what's inside the capillary? Hopefully blood. And then outside the capillary we have the interstitial fluid, which I am usually in class calling tissue fluid. And in the tissue fluid is mostly water, shown with the blue circles. Water, water, water. And both inside the capillary we have water, and outside. And inside the capillary we have proteins of different sizes, and also some protein outside the capillary in the tissue fluid. And also remember that when the blood comes into the capillary bed, it's coming from the heart. Yay, yay. When it leaves the capillary bed, it's going to the veins. The other really important thing that you need to know about the capillary is that it is semi-permeable. Really important to understand what that means, semi-permeable. If something is semi-permeable, in some way it has to have some holes in it, and the holes have a defined size, so that big things, like this big protein, cannot fit through the holes, but small things, like this water molecule, can fit through the hole, and they're free to diffuse through the holes. And when we say that something is diffusing, we mean that the substance is moving from a place where it is high concentration. Remember, the brackets mean concentration. The substance is moving to a place where it is at low concentration. So wherever there is a lot of the substance, it will move to where there is less of the substance, and in effect it will spread out. So now that you have remembered all those things about the water and the protein and the semi-permeable membrane, now we can start to understand how the plasma proteins affect blood pressure. So we know that water can go back and forth across the membrane however it wants to. And in this scenario you can see that for water, good old H2O, outside the capillary it's at a high concentration, and inside the capillary it's at a low concentration. But for plasma proteins, which I'll call PP, they have the opposite scenario. So outside the capillary, you can see that there really aren't that many plasma proteins. In this picture there are 3. So on the outside of the capillary in the tissue fluid, the plasma proteins are at low concentration, and inside the capillary you can see that, wow, there are a lot of them in there. So that they are at high concentration inside the capillary. And remember, the reason why there are a lot of plasma proteins in here is that they are too big and they can't get out. They're too big to fit through the holes in the capillary, so they're stuck in there. But that's a good thing for you. So because the plasma proteins have to stay in the capillary, they just stay. But by doing that, just by staying, they are also pulling in water. So water will move down its concentration gradient through the holes that are small into the capillary, and the plasma proteins pull in water. So if you have a tube or a capillary and you're and you're pulling in a lot more fluid or a lot more water, that means overall you have more pressure on the inside of the capillary. So it's like if you have more water in a hose, you have more pressure inside the hose. So if you increase plasma proteins, you increase blood volume, or BV, and you increase blood pressure. This is why, no, go back. This is why in people who are really malnourished and don't have enough protein in their diet, they tend to have low blood pressure. So hopefully this video has been helpful to you, and watch for another one coming soon to talk about your favorite, sodium. Sodium video is coming.